Hey everyone, welcome back to the RAG tutorial series part 21. So far, we have built our RAG application with 7 different data sources. And those sources are PDF, URLs, SQLite, database, Postgres database, document database, which is a MongoDB. And recently, we have added a CSV data source as well as the RESTful API. In today's video, I'm just gonna start introducing a new data source, which is a time series database, which actually makes RAG-powered AI application more intelligent. It's not gonna be a very easy thing to implement. It is going to be a little bit tricky, a little bit challenging, but I will try my best to keep it as simple as possible so that everybody can understand what happens when we integrate the time series database, to our RAG-powered AI application. So there are multiple ways on which time series database actually get used, right? It could be used for just storing a sensor data, financial metrics, system metrics, logs, the patient, continuous monitoring and all those kind of things. There are many more use cases where time series database gets actually used. Once we have, time series database integrated, right, then we can just make a lot of intelligent application, right? What are those? You can see on my screen, like we can use this application to monitoring our IT operations. We can use for financial analysis or also use to just have a trading predictions, right? We can also monitoring, the patient health. We can also use for environmental monitoring. These are few scenarios where we can use this, right? So what precisely we need to do when we have to integrate a time series database? The very first thing which we have to understand data ingestion and the storage. So I would like you to take you to the InfluxDB, which I have set up with the Docker. This is how it looks like. So what I'm currently doing with this time series database is I'm just trying to extract the data for all the Docker containers which are running in my Docker desktop, right? I can quickly show you like how many containers we have. So we have MongoDB, Postgres, InfluxDB, and inside this Docker Compose, I have 5 different containers. So basically we have 8 different containers, which you can see on my screen, right? These are the one which we have, right? So what I'm trying to do with my Python code is, it is just extracting the stats for all those Docker containers, like a CPU usage and the memory usage, and then it is just storing into the InfluxDB. And I will just explain each and every line of code, how you can set up an InfluxDB, how you can extract the data and just load to the InfluxDB in the next part. I have already published a tutorial series where I explained all those things. You can find the link in the description as well as on the right top of your screen, where you will get to understand how the InfluxDB works, how you can load the data to the same, right? So that is where we have to do the data ingestion and the storage. The next thing is, once we have a data stored, we have to extract that data. But here, the thing is not going to be the straightforward, because, the data which we store in our time series database, it is having a different way of getting stored, right? So let me just quickly show you how the data looks like. This is how the data actually gets stored. We have a measurement, inside the measurement, we have tags and the fields, right? So this is my measurement, which is Docker container stats, and these are the container name. And the values which we have a numerical representation of all the fields, right? But when it comes to, utilizing the time series data, user is going to ask a question in a natural language. So he will be asking a question something like, I just wanted to know all of a sudden why my application CPU usage just increased to 90% or 95%, right? So it will be asking a question in a natural language, and we have to convert that into a time series query, which will provide us a proper data. That proper data, once get extracted, is going to in line with our query as a context, and then large language model comes into the picture, where it is going to do its magic and provide us the probability and the cost why, all of a sudden, for my payment service, the CPU usage just got increased to 95%. Right? So that is where the query interpretation part is going to be a little tricky and challenging. Then the data indexing and retrieval, this is again going to be a little bit different what we used to do so far with the other data sources. And this is really going to be very interesting for you to understand. Right. And then the last part is, as usual, augmentation and the response generation. This is simply, whenever you are going to raise a request, we have to just create the proper context. And that is where this augmentation will come into the picture. We will be just extracting the data, aligning with the question to just have a proper context. And then we are going to raise a request so that, LangChain can request to the LLMs to generate the response based on the context which we have fed. Okay. So what all use cases, can be there if we have such application where, time series database is integrated. The very first thing is IT operation monitoring. So we can understand the system health, we can debugging some performance issues and predicting a failures. The another use case could be a financial service under trading. We can analyze the stock trend in the market indicators because all those attributes are actually being stored at the given point in time, and that is where the time series database actually gets shown. The next probable use case could be energy management and the utility, like monitoring the power consumption, predicting a demand for, all the utilities which we have, right, within the energy management. Healthcare, it's a very important, a very interesting thing. We know that, whenever any patient we have in a hospital, it has to have a monitoring for each and every passing moments, right? That is also where time series database is very handy. And then we can, if we have enough data points in our time series, then we can build some kind of application which will help us to just monitoring the patient remotely. If we have a, networking in place, for example, if one person is having is there at home and we have some sensors, some devices, install on the human being, and then that data can be sent it through the network to the one's central repository, and that is where our application is running, and it can keep tracking and just keep predicting and tracking, whatever the important attributes we want to monitor. The last but not the least is industrial IoT, which is Internet of Things and the manufacturing, right? So wherever we have a data points which is being stored at every moment, that is where we can include or add our AI intelligence to just make it, more intelligent decision and the informed decision. So these are the 5 use cases, major 5 use cases, but wherever you have a time series database, you can always utilize the power of RAG-powered AI application with large language model to make your application more intelligent. Okay, so for our use case, what I have picked up is IT operation monitoring, because this is where every software developer is interested in. So if you have an application or the services which are running, you are always interested in knowing, what is going on with your service or your application, right? So as a SRE, like site reliability engineer, needs to understand the system performance issue, right? So it can have, this is just one of the example where we can we would like to understand what caused the spike in API latency for the payment service in the last hour, and were there any related alerts, right? That is where, our RAG application will come into the picture, where it is going to retrieve, API latency matrix, and we have to make sure that whatever the API latency, whatever the matrix we have for our application is actually being stored in the time series database, as I just showed you right here. If you will see, for every second, our data is actually being stored here in a time series, and you can see, like, we can just understand the data. You can just see all those continuous line, which is just denoting the memory utilization for all the Docker containers, right? So augment and generate, we by now, if you have been following since, starting of this video, you understand what is augment, what is generate, right? So what we would be expecting, right? So basically what our application is going to do to respond to the question of SRE person who is interested to know the spike in API latency for the payment service in last hour and where there are any alerts, right? And that is where, what it is going to retrieve, like fetches API latency metrics, meaning all the data points from the time series database, like, network throughput and all this stuff, and whenever there is any alert and all those kind of stuff, I will just try to, have some dummy data to just try to, mimic this situation as close as possible. Right? So it can just give us at which point in time, we are having the CPU utilization as 10%, right? So LLM receive this data, might respond. The API latency for the payment service spiked to 500 millisecond at this point in time. This correlated with a sudden increase in the CPU utilization on server payment for 3 to 95% and rise the database query time for the user authentication period. An alert for high CPU was triggered at this point. No significant increase in error rate was observed, suggesting performance. This is really going to be very helpful. And let's see how far and how close we can just build this kind of response from our application, to make this more intelligent and more suitable for the real time. Right now, very high level workflow, like how it's gonna look like. I'm just trying to keep this as simple as possible so that everybody can understand. The very first thing which we have to do whenever user is asking this kind of question, like we have this, what was the spike in API latency? At that point of time, we have to understand like what kind of question is being asked and what kind of matrix we have to extract. And that is where we have to write our intelligent code to understand that. The second thing is extracting a parameter. Once we understand, what kind of question user is asking and what kind of matrix we or trend user is requesting, and based on that, we have to really find out the time range and the condition, what exactly is being requested and what kind of data points we have to extract. The third thing is we have to generate the query, because once we understand, what precisely user is requesting in natural language, then we just convert into what all precise data points we need, what all columns we need, what kind of situation he is trying to understand. Based on that, we will just try to, create our query for our time series database to understand how we can extract that data. Once that query is formed, then we should be able to get that data out. And once we have that data out, then, it's a straightforward mechanism or the flow which we have been doing for other data sources. Like we can just create the summary, or we can just, ask, LM also to, what kind of additional questions can be asked, which can be answered based on the data which we have in our time series database, right? So again, combining a context just because so that, LLM can provide us a more precise and intelligent answer. And then, we all know this, how we just combine the context with the question, and then how LLM responds back to us, right? So that's pretty much it, which I wanted to cover in this video. In the next video, I will just start, explaining how we can set up the InfluxDB, what could be the best way to just get the data loaded properly into the InfluxDB, because InfluxDB is the one which I'm going to use for the time series database. But the logic and the flow is going to be same for all kind of time series databases. The only difference will be the SDK or the Python client you're going to use, how differently that library is actually structured and built. I hope you enjoyed this video. This is what I want to cover. I didn't want to do any kind of coding related stuff in this particular video. But this is just a basic foundational stuff, because now we are getting into the more challenging and the interesting area where we are going to make our RAG-powered AI application more intelligent and suitable for the real-time use. If you really like this video, please give a thumbs up. And if you feel this video can help your friends, colleagues, and group, please feel free to share with them. And if you haven't subscribed for my channel, please do subscribe for my channel as well. Or if you have any specific use case or any specific data source you want me to just integrate in the RAG-powered AI application, please put that in the comment section. I would love to integrate that new data source which we haven't yet integrated. Thanks for watching this, and as always, stay healthy and keep learning new things.